Hello everyone, welcome to Dinesh Tech Bytes. Today we are going to see about how to do encryption and rest part 2. If you haven't checked out the part 1, please go through it. You can find it in the top right corner of this video. Without that, few concepts that we are discussing will be difficult to follow in this video. Agenda for today, quick recap from the previous session and what is the KMS provider, how to configure it, what can go wrong when we configure these external KMS providers, how to debug it and how to fix it, and how to develop our own KMS provider if you want one. Yeah, this is the sample configuration that we used in the previous video to encrypt the secrets with this encryption method. I am going to show you the complete list of configuration today. Yeah, if you see here, basically we can provide multiple resources. For example, secrets, config maps, your own custom resource also we can specify, and we can specify what are the different providers we want to use to encrypt it. Now, from the previous video, you will be able to understand that any new secrets that are getting created will not be encrypted. And these are the keys that will be used to decrypt the keys that are present already in the etcd. And we can create multiple resources, and we can say we can encrypt multiple resources using different keys and different methods, different providers. And we are saying events of resource of type events don't encrypt at all. So we are saying identity equal to the empty. So which means events will never get encrypted. And we are saying anything that having .apps at the end, using this encryption provider encrypted, and any other resources encrypt using this provider. Because we specify events here, even though we specify encrypt everything, events will not get encrypted. So if you want some resources to be not to encrypted, put it at the top and specify providers equal to identity. And the other resources you can specify below. Yeah, so list of providers we have. We have identity, like no encryption. We have AES CBS and AES GCM, like different encryption methods we have available. We have KMS1, KMS V2, and we have something called secret box, again, and different encryption. I'm not going into the detail of what each and the encryption will do, but we have different options to do encryption. Yeah. Today we are going to see about this KMS option, which is the external key management service. So what is this? Yeah, a quick points to note. Only one provider will be used for encryption, which is the first one. Other providers will be used to decrypt the data that is present in the etcd. If no keys are able to decrypt, we will be seeing the failure saying unable to transform the particular key, because this key has been encrypted with a particular encryption, but we are not having that key to decrypt now. So we will be seeing this error in the API server. For example, if we lost that encryption key completely, the only option we have to recover from that case is to delete that secret directly in the etcd, or delete that resource directly in the etcd. So it is better to keep that encryption keys safely. Yeah, let's jump into the today's main topic, which is external key management service. So in the previous approach, where we have this encryption key present in the API server, one issue is if the attacker is getting into the etcd, they will not be able to decrypt until they get access to the host or the API server. But if they get into the API server, they'll be able to decrypt the data that are present in the etcd. So we are going to go with an external key management service, which means instead of storing the key in the file system, the keys can be present external. For example, each cloud provider is today giving their own KMS solution. For example, Azure is giving the Azure Key Vault solution. Google is providing their own security key management service. Similarly, Amazon is giving their own solution. I can quickly show you that. Yeah, if you see, this is the Azure Key Vault solution, and this is for the Google Cloud, and this is for the AWS, which means we can ask our API server to talk to these services while encrypting it, and talk to the service while decrypting it. Yeah, see how to do that. In this diagram, we are having the KMS, which is part of the cloud, and we can instruct API server to talk to this KMS service for encrypting and decrypting, which means our API server should know how to do authentication. What is the API schema? For example, if it is Azure, it is Key Vault. If it is Google Cloud, it is key rings and other concepts. Similarly, if it is AWS, it will be different API, different request parameter, request different response, which means our API server should know all these things. This is not a scalable solution. So what the Kubernetes or Kubernetes community has done here, so they have their own KMS provider running as part of the control plane, and the API server will talk to this KMS provider. Now the KMS provider is specific to each provider. For example, if it is Google Cloud will give their own KMS provider. Azure will give their own KMS provider, which means this KMS provider will know how to talk to the KMS service that is provided by the particular cloud. This KMS provider will take care of authentication, API schema change, upgrade, everything. It will be taken care. So let's see how to configure this KMS provider to our API server. So we can say encryption config, very similar to before. Instead of any specific provider, we can say KMS. It's a key management service, and it can cache like 100 keys and use this endpoint to talk. API server should use this endpoint to talk to the KMS plugin or KMS provider service. Now we are naming it as a KMS plugin. Now in this socket, any provider can run and they can listen and do encrypt and decrypt. Now, for that, we have this defined interface. For example, we have this KMS V1 and KMS V2. Each one is having different interface. Let's see how the KMS V1 interface will look like. Now they are saying, this is the protobuf for the KMS service. Let's search for interface here. Yeah, so we have this interface. So now we have this encrypt method, we have this decrypt method, and we have this version method. So any KMS provider, if they expose these three functions, and if they're able to run in this any socket file, our API server will be able to talk to this socket file and use these functions like encrypt, decrypt, and will be able to encrypt the data. And the KMS service will be able to talk to their cloud specific data and do it. Now let's quickly go into the example KMS providers. So we have this Azure Kubernetes KMS provider, Google KMS plugin, then similarly AWS encryption provider. So if you see here in this one, if we search for this interface, which is defined in the common protobuf, it will get implemented. Similarly, this plugin will implement this. Similarly, this plugin will. So which means if you want to develop your own KMS plugin or KMS provider, you can implement these three methods, and internally you can do whatever you want. So if you see here, this is Azure specific KMS, so which means it will talk to the Azure's Key Vault client to do encrypt and Azure's Key Vault client to decrypt. So it is our cloud specific. It will know how to do authentication. It will know what is the request, what is the response, but it is providing a common interface for our API server to interact with. Yeah, now we have seen how to configure it. Yeah, now similarly, if you want to develop our own KMS, we can follow the same protobuf and we can follow it. And whenever the KMS plugin or provider comes up, it has to create the socket file and listen for the encrypt and decrypt methods. And also it should have a version method, which should tell what is the current version of this KMS provider. All these things are defined in this, the protobuf. Yeah, so these are the commands that we have used to list the keys and inspect a key in the etcd in the previous video. You can refer it in this post, dineshba.github.io. You can refer all these commands that we have used as part of this session. Here, what are the things can go wrong if you are using external KMS provider? So if you see, API server will talk to the KMS provider, and KMS provider will talk to the KMS service that is running in the cloud. So there can be issue in the socket file that got created. or the socket file is not mounted into the API server pods, which means API server cannot talk to the socket files. Then KMS provider is having some issue, like KMS provider is not able to start it because it is not able to authenticate, or whatever response that public KMS is giving is not valid, or there is some uh, rate limiting that is happening in this KMS, because of which KMS provider is not able to encrypt and decrypt. So these are the things that can go wrong when we are using this KMS provider. So using the pod logs of KMS provider and the pod logs of API server, we should be able to debug and get what is the current issue if it is something happening. Yeah, some extra bytes, some few things that I admire from this whole design, how they introduce this KMS, how they introduce this encryption as a whole to the Kubernetes. Like some design things that I admire, which we can take it and put into any things that we design. For example, extensibility, supporting multiple encryption providers, like statically putting into the keys into the file system, having an external KMS, and they are also bringing in V2 with some improvement. So they keep on extending this with the different providers. Any resource, not restricting only to secrets. It can be secrets, config maps. It can be user-defined custom resources also can be encrypted. It's a complete solution. They have thought through what to do when in case of key rotation, what to do if you want to completely remove the encryption, because we have this first provider always encrypt or other providers decrypt. We will be able to do key rotation. We will be able to do remove encryption completely if we want. Also, we can move from one KMS to another KMS. For example, let's say we are using Google KMS, right? For some reason, we want to go to Azure KMS. Then we can define our Azure KMS as the first thing, and we can keep this Google KMS as the second thing. Once we migrated all the secrets from the Google KMS to Azure KMS, we can get rid of the Google KMS completely. So all the things we can do, it's a complete solution. And the KMS is a cloud agnostic solution. Any gRPC server which implement these three methods, like version, encrypt, and decrypt, will be act as an KMS provider. So because Kubernetes is well adopted, it's been running in multiple cloud, even in on-premises, which means this solution should be cloud agnostic. They have also considered this. Yeah, thank you. If you learned something in this video, please like it. If you have any suggestions or inputs to me, please comment it. Subscribe to my YouTube channel for more content like this. Thank you.